For this lesson, we are going to be focusing on multiplying and dividing integers. In the past, you probably thought about multiplication as repeated addition. Well, thinking about multiplication as repeated addition can help us better understand integer multiplication. If you consider the following example, it might help to make it make more sense. If you think of -3 times 2, well, this just simply means -3 2 times. So that's -3 plus -3, which is -6. The same thing is true for -3 times 3. That's going to be -3 plus -3 plus -3, which is -9. I want you to notice that in both cases, a negative integer is being multiplied by a positive integer, and in both cases, the answer is negative. So consider the following pattern. We have -2 times 3 is -6. -2 times 2 is -4. -2 times 1 is -2. -2 times 0 is 0. -2 times -1 is 2. And -2 times -2 is 4. As we are multiplying -2 by these integers, as these integers decrease in value, what is happening is that your product is increasing in value. So if I'm multiplying a negative by a positive, I'm getting a negative answer. When I multiply a negative times a negative, I'm getting a positive answer. And as you know, anytime I multiply by 0, the product is 0. What I want you to notice is that when both integers are multiplied and they're negative, then the product becomes positive. Now, just like addition and subtraction, multiplication and division are inverse operations, which means they undo each other. Therefore, the same rules apply for dividing integers as multiplying integers, and this is why. If you multiply 4 times -2, your product is going to be -8. Now we know that division is just the opposite of multiplication, so we can take this fact and say, well, -8, if I divide that by 4, I'm going to get -2. The same holds true in this example, where -4 times -2 is a positive 8, and so therefore, 8 divided by -4 is going to give me a quotient of -2. So here's the big idea. When you're multiplying and dividing integers, if the signs of the two numbers you're working with are the same, the answer is going to be positive. If the signs are different, the answer is negative. You don't change the way you multiply the numbers, you don't change the way you divide the numbers. All you have to do is pay attention to whether the signs are the same or different. So using those rules, we're going to work through some multiplication and division examples together. If you consider example A, -7 times 2, well, 7 times 2 is 14. And then I ask myself, are the signs the same or different? I have a negative and a positive integer. If the signs are different, my answer is negative. -14. It's really that simple. Now, if I go to example B, I have a -8 times a positive 3. Signs are different, so my answer will be negative. 8 times 3 is 24, so my answer is -24. In example C, I notice that I'm multiplying a negative times a negative. My signs are the same, -6 times -5. Well, I know that 6 times 5 is 30, and so my answer is going to be a positive 30, again, because the signs are the same, so my answer is positive. And then my last multiplication example is -10 times -17. Signs are the same, so my answer will be positive. 10 times any number, you may recall the pattern. If you multiply 10 by a number, you simply add a 0 to the end of it. And so 17 times 10 is 170, and my answer is positive because I recognize that the signs are the same. Now, what if you have two positive numbers? Well, anytime you've worked with two positive numbers in the past, your answer's been positive, so that remains the same, and that helps you to recall the rules if you happen to forget them later on. And lastly, we have our division examples. So, if I'm working with example A, it's negative 27 divided by 9. I recall the fact that 27 divided by 9 is 3, and then I just remember that if the signs are different, the answer is negative. Signs are different, I have a negative and a positive, so my answer is negative 3. If I go to example B, I have 35 divided by negative 5. I have a positive integer divided by a negative integer. Signs are different, so I can say, well, my answer is negative. And I know that 35 divided by 5 is 7, so 35 divided by negative 5 is negative 7. Moving on to example C, I have negative 32 divided by negative 8. Well, 32 divided by 8 is 4, and my signs are the same, so my answer is positive. Negative 32 divided by negative 8 is positive 4. And lastly, I have negative 416 divided by negative 4. This isn't something that I can simply throw together with my memorized division facts, so I can come over to the side and first notice that it's a negative divided by a negative. Well, when I look at a negative divided by a negative, I see that the signs are the same, so I know my answer is going to be positive, so I don't have to worry about the signs when I come over to the side to do my work. So if I have 416 divided by 4, 4 goes into 4 once, subtract it away, bring down my 1. 4 doesn't go into 1 evenly or at all, so I have to put a 0 to hold the place. I bring down the 6. 4 goes into 16 4 times evenly. I'm left with nothing, so I have that 416 divided by 4 is 104, and just to go back and double check, both of the signs are negative, which means signs are the same, answer is positive. 416 divided by 4, negative 416 divided by negative 4 is a positive 104.